All right, we're live. Welcome to Dive into World Building. Sorry about the late start. Today we have a really awesome guest on. This is Dr. Heidi Stauffer, who is fabulous and geologistic. And
I don't know if that's a word, but
yes, because I make up words, what I do.
Awesome.
But I am super excited to have you on the show, Heidi, and you are a perfect person to talk to us about geology and world building because Heidi has interest in both, obviously the geology PhD and then also science fiction and fantasy. So yes, I'm just very excited to have you on the show. And I think geology is, I'm not going to say under-considered, but I think it's often under-scienced in fiction.
Yeah, I think so too. But I have a different perspective than other people. I think it's also overwhelming.
Mm-hmm.
And people don't want to they don't want to take that dive. You don't know where to start.
Yeah, start at the datum and work backwards.
I mean, you don't want to invent the universe.
Yeah.
So I think people just get overwhelmed. They don't know where to start.
So where would you start?
I like to start at the solar system level.
Okay.
But then I'm pretty hardcore.
Yeah.
I think it's perfectly fine to start at the planet level. But I like to figure out where my world belongs. I mostly do hard science fiction, so I like to figure out where my world belongs in relation to other things. Mm-hmm. Sometimes I may want other planets in the system that are part of the story. So that's why I want to look at the system itself. Mm-hmm. But a lot of people make the mistake of making an entire planet that has the same climate.
Yep.
And that does not happen. It is like not possible for it to happen. Even those frozen planets are different on different parts. So even the frozen moons are different in different parts.
The sociology version of that is a planet with only one culture.
Right. Exactly. Yeah. Yep. Mm-hmm. That's a perfect analogy. Yeah.
And actually, I love the idea of starting at the solar system level because that's where that's where like all the stuff comes from.
Yeah.
Like, you don't know the story, you don't know what your planets are made of, and then you don't know what they're doing.
Right. Right.
Yeah.
Right. I guess for fantasy, you might be able to start more at a continent or depends on how far out you go in terms of macro or micro scale. But I think starting at a continental level is probably good. I mean, that's just my feeling on that. It depends on how far out you want to go. Do you want to go for the whole world? Then you probably should do the planetary level. Do you want to stay in a kingdom? Then a continental level is fine.
Yeah.
Geology. Because you can sort of make up the stuff outside of it. Mm-hmm. Fit what you're trying to do.
Makes sense.
Does it?
Well, yeah. It's a scale. It's a sort of a scope question, right?
Mm-hmm. Mm-hmm. Right, and you have more control at the closer in that you go.
Mm-hmm. Mm-hmm.
So, and you can always, I mean, I don't have any issues with people using known Earth climates. That doesn't bother me at all because statistically, there is likely a planet like Earth somewhere out there in the universe. Mm-hmm. So, or if you want to go into more theoretical physics, there are maybe alternate universes with similar characteristics.
Yeah.
So I don't have any problem. Sorry?
Like, I have a question though. Does it work for you when people like, I actually can't think of an author at the moment. But when we're trying to discuss, say, Titan,
Okay.
and we say, okay, well, there, basically, water ice is your equivalent to bedrock.
Okay.
And you can watch, like, people with some geology or planetology will go, yeah, okay, I'll give you that. But people without it just go,
Yeah.
you know, like, I don't even understand what that means. And you're like, well, we won't get into the greasy petroleum-like stuff that lives on top of it then.
Yeah, that's a little more difficult to sort of parse out. But the hydrocarbons that are liquid on the surface of Titan behave like water because they're a liquid. And I teach high school. So I actually just did this section look in my chemistry class looking at Titan.
Awesome.
What's on Titan. So, and how it's related to Earth. So one of the things that Titan's atmosphere is missing is free oxygen.
Yeah.
And on Earth, free oxygen came from life. So that's something that you're going to need to find another way to get free oxygen if you don't have sort of, like if you're exploring a new planet that has free oxygen, you have to find another way to get it there. Because the way it happened on Earth was life forms that produced it as waste. So that's
it's actually corrosive.
Yeah, and it's actually not it's not good for lots of living things.
No. No, that whole thing of once there was enough of it pooped into the atmosphere, like lots of things died because of that.
Yeah, one of the mass extinctions in the far, far past. Yeah, so that's something that you have to think about, is how you're going to get free oxygen.
Well, I love that you're doing chemistry as well, because that's one of the other questions that I can't tend to get a bunch is, let's find life forms that aren't carbon based. And I'm like, but you don't understand how versatile carbon is.
Yeah. And the other thing is you can look at atomic structure. So there are some similar elements. Often what's used in some sci-fi, I know Star Trek did it, was silicon based. Right? So, but those are going to be life unlike we've ever known. And I don't know how you would get more in depth with that.
Yeah. Well, I mean, so I guess what you're dealing with if you're going to be building silicon-based life forms is the problem of the the theory is too powerful, right? You don't have a lot of guidance on what to put. You have a lot of freedom to put what you want, but absolutely no indication of whether it would actually be at all plausible.
Right.
You just kind of have to say, I am waving my hands at you.
Exactly. So I think that chemistry is super important, because geology is actually chemistry, biology, physics, ecology. And people don't realize that. They're like, you just study rocks. No, I have to understand everything pretty much every other scientist does, including the math. In order to understand the geology. So my PhD was actually in climate modeling. But I have a traditional geology bachelor's and master's degrees. So you can make that leap. It's not like, it's because I had all the background I needed, except for the programming, to get there. So I had all the physics. I had to brush up on some of the math. But I had all of them, and I have like the big picture, long view of climate because of that. So I think that's another thing that people don't realize, is that you have to look at scale. So what is your scale in terms of time and in terms of your physical world.
Mm-hmm.
Right? So there are things that you can't do, like you can't have, you know, super giant creatures on, you know, planets with, yeah, you know what I'm talking about. You just can't, there's just a physics issue. And I've talked about this when I was TAing. I TA'd a class called Natural History of Dinosaurs. And we talked about this a lot, which is the body size versus metabolism and then versus gravity. So there is a certain maximum land animal body size based on Earth. And you're going to have to redo all the calculations for a whole different planet configuration to figure out.
And it's going to be like all of them, which I think is something that people don't tend to notice when they're writing. And especially the 50s and 60s and early 70s science fiction, when we still thought that the Earth dried like an apple into mountain ranges.
Right.
People working from those first premises, you know, yeah, you're going to have those planets with low oxygen and big, huge insects, which does not work at all.
Yeah.
But they didn't know that. We didn't know that.
Right. Big insects are on high oxygen planets. Just
yes, they are.
For those people listening along at home.
Yeah. That's definitely true. Yeah. So,
Yeah, I'm still trying to figure out. I've been trying to watch the botany going on, paleobotany, for Hell Creek formation. Because, okay, we have all these great dinosaurs, right? What did they eat?
Yeah. What did they eat?
And the answer is, well.
Yeah, exactly.
So I'm just sort of like, okay, do I take that as freedom to have them eat whatever I want them to eat? They can eat, you know, dryer cleaning bags if I want.
What is the climate
but
like?
I want something that's actually going to work. I mean, like,
what lives and what grows there, basically.
Yeah. And a lot of the botany hasn't been done. It just isn't there.
Well, a lot of stuff isn't preserved. Yeah. So there's a lot of sort of educated guesses that people have to make.
Yeah.
Based on what they can tell about sort of the physiology of whatever organisms live there. What they might need to survive.
Yes.
And then what the climate was doing. Because you obviously can't have redwood trees in the desert, but you'll have to, and that's what I mean by sort of earth science and geology being overwhelming in terms of the world building, because once you start with something, everything gets sort of, it's like a domino effect. You tip over one thing and then you're like, wait, I got to change that and that and that.
Yeah, it's very much like study design. Oh, but you know, I've got the whole structure and now I'm going to change one variable and everything falls apart.
Yeah. It is kind of difficult to make sure that things are working and that all things can work together in some way or another. But it's not impossible, right? And it doesn't preclude certain things. I was on several panels where we discussed, would you rather have science or would you rather have story? And I'm like, you don't have to make this choice.
Yeah.
Right? It is not a dichotomy, right? But there are some places where, and I fully accept this, in the interest of story, you might have to tweak the science a little bit. But you have to do it in sort of a plausible way, right? Like for some, I can't remember. I've read some novels where they were pretty creative about how they did things in terms of making it fit in a way that made sense. So that's just my personal take on but I think people get super overwhelmed, and I wouldn't like eliminate certain organisms because you think that you just can't do them. There might be ways, right? So if you had a planet that was a bit closer to the sun than Earth and warmer, right, you could still have places where it gets below freezing for water. So it depends on where you put them, how it orbits. Yeah. So all of that stuff is, all of that stuff is doable. You just have to adjust your expectations.
Yeah, sure. Because I mean, you could have. I mean, we have Snowball Earth. It's just a time frame.
Yes. Yep.
But it's one of those. That's one of those things where attempting to discuss that with lay people gets you into conspiracy theory areas.
Oh yeah.
And you're just like, but no, there were no ice bats. But okay, fine.
Yeah. But the Snowball Earth thing also has to do with the planetary configurations in the solar system because and the life cycle of the star that's the center of our solar system, because back then it was 25% dimmer than it is now because of just that's its life cycle. So that's something that you can always tweak, right? You can have some sort of near, like maybe knocked it out of orbit a little bit, or, or it's on an elliptical orbit. So certain times, like we have ice ages, we're on elliptical orbit. When everything aligns correctly, we have a really extreme glacial episode. But there are times where things don't quite line up, so you get milder versions, or it swings in the opposite direction, which it's done many times in the past. After you have an extreme glacial episode, it'll swing back so it's warmer than it is today. So there are lots of considerations that you can have. And you don't even have to go into any of that if it doesn't work for your story.
Well, I mean, I do think so. One of the hazards, I think, is that people may listen to us talking about solar systems and planetary stuff and go, well, yeah, but how does that affect my story? Like on the ground, what do the characters do and stuff like that. And the thing is, it does in lots of ways. But I'm wondering if we could spend a minute talking about how those threads connect. Because I mean, at the very least, what you're going to be dealing with is, how the seasons work, what they are, and how people talk about them are going to have everything to do with the size of the planet, the speed of its orbit, the angle of the planet, all of these really important aspects of
the limits of your climate.
Yep.
Right. So lots of factors factor into this, and I'm not saying you should go through and do all the physics calculations because that is not feasible, and I wouldn't recommend it anyway. You don't want to deal with that. But I mean, when I do my own writing, I just look at things that are established already. What is it like on Mars, given its mass, how far it is from the sun, how it orbits. So then you can do the what if scenario. What if it were, 50% bigger, right? Then actually there might be one less planet if it were that much bigger. There should be one planet where the asteroid belt is, but between Jupiter and Mars, it's just too much pulling in different directions to keep a coherent object in that space. So all these things are, I like to start with stuff that's established so you don't have to do extra calculations unnecessarily.
Yeah.
Right? So, I mean, what if Venus were in Earth's orbit? It's almost the same size as Earth. It's the closest of the rocky planets to Earth size. It has had plate tectonics in the past. So there are lots of pluses, and then you actually cool it down, what might happen? So, I mean, right now it's way too hot and way too corrosive for any life as we know it to exist. Even our instruments get dissolved.
Yep.
They don't last, they last minutes at the surface if they make it there.
Mariner.
Yeah.
Well, that was, I always wondered whether George Lucas just got really lucky that he posited that Tatooine had 3 or 4 moons, but he didn't give it a C, which would have been horrid.
Yeah.
Trying to figure out what the tide cycle would be.
Yeah. The tides are really interesting. It's if you want to look at some tidal effects, you should look at some of the moons of Saturn and Jupiter. And
Enceladus.
You can see the tidal effects of what's going on there, and it's pretty well established. People have done lots and lots of mathematical calculations and modeling to establish how that affects. So if you want to see what it's like, to put your civilization on a rocky, large moon, like Titan orbiting a gas giant, you can see what it might be like with the where the sun would be, how you would see daylight, because half the time your gas giant might be in the way.
Yep.
So, but I like to use established science. So I don't like to do a lot of research on my own. I like to go to NASA, the NASA websites. For climate, I like a lot of the government sites like NOAA. For hardcore, like Earth-based geology, most of that is U.S. Geological Survey. When the government isn't shut down, you can get a hold of those websites. Let's see. I also like to look at, there is a really good climate resource called realclimate.org. Let me put it in the chat box.
Sure.
It is it's where real scientists deal with controversies or new research. There is a whole start here section that's on the right-hand side of the website, I believe, if it hasn't moved around. But there's a whole beginners start here. Main ideas. Bless you.
Sorry, I'm quietly exploding over here.
That's one that is not government linked necessarily. If you want to delve a little deeper into climate, there is the Intergovernmental Panel on Climate Change. Their executive summaries are written for politicians, basically. They're written for non-scientists. So those are always good to look at in my estimation. I wish I could think offhand about some books.
I can think of one, which is Alan M. Steele's Coyote. He set his civilization on a moon orbiting a gas giant that's basically in the same kind of solar system we have. And going to the culture aspect you asked about, Juliet. You know how we call really strong liquor moonshine?
Yeah.
Well, their gas giant was called Bear. So their really strong locally brewed liquor is Bear Shine.
That's cool.
Yeah.
That's cute.
Yeah.
Alan does a good job.
Yeah, so that, I mean, there's many options if you look at already what's been established. NASA has really good web pages and sub-sites on all the different things. Because I'm a teacher, I go to all the education stuff. That's perfectly fine too. Those education sites are really good. Some people are more visual learners. They want to watch videos. So as a teacher, I always use the PBS website. They have, it's called PBS Learning Media. It's actually the teacher, the educator section. And you can search by subject, you can search by grade level, you can, yeah. So they have like quantum physics stuff on there. It's way cool.
That sounds way cool. I may be down that rabbit hole a long time.
It's not really a loss if you ask me.
No.
Because I watch them while my students are watching them, so I'm like, oh, this is fun.
Well, that's awesome. It's really great when you have a great resource like that. I want to ask the mountains question. I want to do a little bit of plate tectonics with you, if that's okay.
Sure.
So you've got somebody who's writing, and they want to make a map of their country, and they plop some mountains down. Yeah, we should be thinking about plate tectonics, right?
Yes.
What kinds of things should somebody heading in to hey, I'm going to invent a continent and put some mountains on it kind of stuff, what should they be thinking about?
Okay. In terms of plate tectonics, there are 3 types of plate boundaries. Does everyone, should I go back and talk about plates and how they move? And
very briefly, how about that?
Okay. So the Earth is divided into layers based on density and rock type. And some of, there is a layer of the Earth that's called the asthenosphere that moves like silly putty. So it is liquid over long periods of time and solid over short periods of time. And that's what the plates are riding on. And the plates are made of rock, basically. And on top of the rock are not just continental crust, continental rocks, but also ocean rocks. So plate tectonics is not continents floating around in the ocean. It's beneath that. Can you tell I teach high school? It's
awesome.
It's beneath that layer is where that silly putty asthenosphere is. And so that's what the plates move on. And they're broken up like ice on a pond. So they're shaped like that. And they're moving, they're all moving. So there are 3 types of ways that these plates can connect or interact with each other. One way is they can be pulling away from each other. These open up ocean basins in general. This is how ocean basins are formed. And then, but when you're opening something up on the other side, you're probably crashing into something. And if you're oceanic rocks, you're denser because they're darker and they're denser. That's just the way they are. And that's why the continents float up above the ocean basins. So when you're crashing into stuff and you have an oceanic plate, it will go down beneath a continental plate because it's denser. If 2 oceanic plates collide, one will be forced under. And then the 3rd type is the type that people in California should all know.
Yep.
It's called a transform boundary. It's where the plates are sliding past each other. And that's what roughly to a sort of first estimation, that is what the San Andreas Fault defines,
Mhm.
is that kind of boundary. So let me tell you, characteristically, mountains are generally formed where things are colliding, but when things are pulling apart, rifting, on the ocean floor, they're pulling apart and they're closer to the magma beneath the surface, the molten rock. It'll come up and make mountain ranges on the ocean basins. So those are what are called ridges, ocean ridges.
Okay.
So the Mid-Atlantic Ridge is one of those. That's an ocean ridge. And it is higher than the abyssal plain. So it looks like a mountain range. When you have two continental plates colliding, you end up with the Himalayas.
Yeah.
And unless you count from the ocean bottom, the highest mountains on Earth on the continents that start on the continents are from continent collisions. And there are some, and you have to also look at the time span, because in the United States we call them young, but they're not that young.
Yeah.
But the coast ranges are fairly young because they're remnants of when the plate boundary was not transform, it was subduction off the coast of California. And things got scraped off of the ocean plate that was going down beneath the continental plate. And you end up with this mess of rocks piled against each other in the coast ranges. And they're mostly metamorphic, which means they're originally they're originally a different type of rock, and they got melted and squished. So that is actually high pressure, low temperature is what's happening. The higher the temperature, the lower you are. So this is really near the Earth's surface is what's happening. So a famous subduction zone is the Mariana Trench.
Yep.
In the Pacific. So it is also the deepest trench, the deepest part of the ocean. So your mountains can exist in the middle of a continent without anything going on because they could be old, but then they can't be sharp peaks like the Himalayas. They have to be like the Appalachians. The Appalachians are an old mountain range from way back, long before. So the Rockies, the Sierra Nevada, and the Cascades. Cascades are volcanic. They're not. They're formed because there is a subduction zone off the coast of Oregon and Washington. When that happens, the downgoing oceanic plate gets melted, and the density of hotter, more liquid rock is less than solid cold rock. So it'll rise up and breach the surface as volcanoes.
Oh, wow. Okay.
Yeah. So let's see. In general, if you have, let's just take the Himalayas for an example. If the Himalayan, so the Himalayas, everyone, the Himalayas were formed when the Indian subcontinent broke away from a supercontinent down in the southern hemisphere called Gondwana, and it trucked north and basically slammed into the Asian continent. And that collision caused a whole bunch of disruption. The Himalayas are still going up. That whole Tibetan plateau is still rising because India hasn't stopped moving. And that happens because there was a spreading ridge down by Antarctica and spread them apart. That's a divergent plate boundary. So when we say, and so the higher, so you have a really high, sharp, new mountain range. Over time, that'll erode down. That is just the way things work on the surface of the Earth, because we have weathering, we have all kinds of stuff going on. So it'll work its way down till it's more rounded, less sharp, like the Appalachian mountain range. And then it could be in the middle of a continent where there was an old collision.
And so, can I ask something? So clearly it is possible for a plate to change directions.
Yeah.
That I find fascinating. Do we have any sense of when such changes of direction have happened and how long they took to occur?
We know about the Himalayas, the formation of the Himalayas. There are actually marine fossils in the top of the Himalayas, and we can date those with radiometric dates. And I'm not 100% sure. I think it's about 50 million. Anyway, I don't want to quote.
Fair.
Not exactly my expertise. So the timing, it depends on the plate, and we're not actually sure why they will change direction, but think of it as a whole bunch of broken pieces of ice trying to jostle for position on a
Yeah, if you want to see where a bend like that is actually recorded in the rock itself, look at Hawaii, because it rotated around it.
Yeah, the Hawaii Emperor Seamount chain, because Hawaii is not at a plate boundary and it is a hotspot.
Yep. And
the way we study hotspots is we assume that the hotspot is stationary and that the plates are moving. We don't know this for sure,
right?
But if it weren't true, the math would be a nightmare to try and figure out what's going on. So we assume that the hotspot is stationary and that the plates are moving over it. And this is just an area where magma is pushing up through in this case, the ocean floor, but in other parts of the world, the continental crust. Yep. It's just a place where magma just keeps coming up.
And our most famous one of that is Yellowstone, isn't it?
Yes. Although there was a recent article that I haven't read completely that put some twist on the fact that it's a hotspot. So you're going to have to go back and read that.
Did you read the latest stuff about the 6-kilometer boundary and there's mountains pointing inward, and that's just so cool?
I didn't see that. Where was that?
Oh my God. I don't know where it was. I will find it. But yeah, they were just analyzing the earthquake that happened in Belize, the 7.8 in like 1991. And below the Moho, there's a ring of different echoes. And it's actually mountain chains on the pointing toward the core of the Earth. And they have basins down there and everything. It's very much, if I was a conspiracy theorist, I would be all over Jules Verne right now.
Too bad we can't take a field trip down there.
I know, right? There was a really bad movie about that.
Survives such a field trip. Hard to get the parent signatures, really.
Well, yes. That whole survivability factor. Gosh darn it.
Yeah, sadly.
Doesn't matter if you survive if you give us the data back.
Yeah.
All right. Well, so that's a lot.
Yes, it is.
I'm intrigued, and I'm glad that you and Kate are seeming to want to exchange items of research, because I always encourage exchanges of research between my friends.
Okay, awesome.
Yeah.
My cat
Yay!
is here. Okay. Let's see. Can we maybe spend a minute or two talking about other ways that geology can create exciting events?
That's really broad.
Yeah, well, okay, so I was thinking of course, volcanic eruptions, which have appeared in fiction a lot. But I was also thinking there are a lot of other things that people don't typically use because they're not necessarily aware of them, like CO2 eruptions.
Yeah.
And you know, there's all kinds of really unusual geologic stuff that can be going on that people don't necessarily think of because they've never heard of it. I don't know if that narrows it down or doesn't.
No, I actually, you said CO2 eruptions, not necessarily eruptions. When volcanoes erupt, a lot of humans consider them toxic gases, but they're just regular sulfur, carbon dioxide. If there's a lake in Africa called Lake Nyos, and beneath it is volcanic activity, and a whole bunch of CO2 built up at the base, and then lakes overturn. So this lake overturned in the middle of the night and wiped out at least a couple villages.
Yep.
Because it basically replaced the oxygen with CO2, and people were sleeping, so they didn't know.
Yep.
And this is a hazard that can happen with a lot of volcanoes because of the gases that they release. There's no actual eruption, but there's volcanic activity. So another example is Long Valley Caldera.
Yay!
Which is one of the largest volcanoes in North America. It is east of the Sierra Nevada, and still in California, between California and Nevada, east of the Sierra Nevada. People have been monitoring it for decades. You know this terrorism, like different colors, the levels, they got that from the volcano warning system.
Oh yeah.
And they came up with that because so Long Valley Caldera is adjacent to Mammoth Mountain, which is a ski area, and it's a major tourist attraction. So they monitor CO2 emissions, and they also monitor ground motion, but vertical motion of the ground. And they monitor the earthquakes. So if you're really interested in volcanoes and caldera forming eruptions, and a caldera is just a giant crater, a giant depression formed when a volcano erupts, and it erupts so much that that the magma chamber is completely emptied out. And then because there's nothing there, it collapses back in on itself. But there's a movie that Discovery Channel and BBC did together it's a docudrama. It's called Super Volcano, one word, not the Sci-Fi Channel movie.
Yep.
And they actually consulted with geologists on this, and they screened it ahead of time at the U.S. Geological Survey before they released it.
Nice.
To get their feedback. So there's some stuff that's a little bit for drama's sake, but a lot of it is right on the money. And this is what would happen in a super volcanic eruption. There was one at Yellowstone, and that's where this movie takes place. There was one at Yellowstone about 2 million years ago, 2.5 million, I think, where the ash from that eruption is found out in the Pacific Ocean.
Yep. Also created Big Bone Lick State Park.
Yeah. And let's see. So that's a fantastic movie, by the way. I used to show it when I was teaching labs. I used to show it to my students.
This was, it's called Super Volcano.
All one word. It's just called Super Volcano. But if you search for it, search for BBC or Discovery Channel. Otherwise, you'll get the Sci-Fi Channel one, which is not the same.
Okay.
So
that was the part I wanted to make sure I wrote down.
The most unrealistic things in this movie are that the Homeland Security people deferred to the geologist.
Yeah, right.
And the headquarters of the U.S. Geological Survey in San Francisco, which is not where it is,
Right.
the West Coast, is a big, beautiful building of glass and steel.
Nice.
And I'm like, first of all, you're in San Francisco. I'm not sure all that glass is actually a good idea.
Don't tell the Moscone Center.
Yeah, right. Exactly. But that movie was fab. I really liked it. I did have a little bit, this is my personal belief being a woman of color in science, but I did have a little bit of an issue with the fact that the only people left alive at the end were the two white male volcanologists. So that was kind of an issue for me.
At that point, we just hope that they were both straight.
Yeah. So,
Juliet, you didn't happen to be thinking possibly of methaneclathrates, were you?
Methane what?
Clathrate? It's the structure that methane is trapped with under the seabed and under the tundra, and we've had a lot of those show up as sinkholes. We don't. I guess the postulation is that they could explode.
Yeah. No, and when I was talking about CO2 eruptions, I was talking about the overturning of the lake in Africa.
Oh, okay, all right.
But that was just me misusing the word eruption.
Yeah,
hey,
but
I'll own it.
Methaneclathrates led or contributed to the largest extinction that we ever had on Earth, which happened 250 million years ago at the Permian.
Yep.
They think it was a secondary effect. It was a secondary effect of the initial. What happened was there was a whole bunch of they called them they're flood basalts. So Siberia, a whole bunch of fissure eruption. It basically erupted for 1 million years of just basalt coming out, not necessarily in a volcano, but just there's some remnants on the sea floor, but it filled a basin that was filled with sulfur-based deposit. And that let go a whole bunch of toxic gas. So what happened is that you got anoxia and hypoxia, and then it heated the planet. And then the methaneclathrates, this is what they think happened,
melted.
They bubbled up through the ocean and added to the problem.
Yeah.
So,
yeah, because they're postulating that for the Deccan traps as well.
Yes. Yeah.
Yeah.
Yeah. So that's basically the latest, I think. There may be something more recent than that, but that's the kind of like perfect storm scenario for that largest extinction on Earth. So,
and somebody actually did do a science fiction book about a supervolcano exploding in the US, and unfortunately it was terrible. But if you want to read that, it's called Ashfall, and I'm sure it's a trilogy. But yeah, some of it's like the first 20 minutes I was like, okay, I can deal with this, and then I couldn't deal anymore.
Oh.
Yeah.
I do like Super Volcano. I really was impressed.
Okay.
So
let's just finish by saying that all of this stuff is super fascinating. But as I've tried to point out a couple of times as we're going through, it's not just fascinating in and of itself. It also has direct effects on whether people can survive, how people live, how they measure time. You know, you cannot extricate geology from anything that we do. So make sure that you're, it's a really good thing to be looking into as you're working on your world building. And Heidi, we may have to have you on again at some point.
Sure. Can I add one little thing? Maybe we can talk about this at another time, but
sure.
I was talking large scale, like planet, solar system scale, but geology, and people who live in California should know this, especially in the Bay Area and Southern California, is very relevant to your daily lives and how your house is built, where it's built, what you need to make sure you can withstand certain kinds of shaking. Flooding, I also consider part of a geologic phenomena, and that is also relevant. I used to work in natural hazard disclosure in California, and my counties were Alameda, San Francisco, and Santa Cruz, and then some like Tehama out in where hardly anybody lives. But most common was how close you are to a fault, liquefaction, flood zone, dam break, flood zone. That's what people don't think about. They freaked out. Like there was some flood zone in San Francisco, and some guy actually called me and said, I don't think my house is in a flood zone. And I said, you are, this is the worst case scenario when the dam breaks on the reservoir that is uphill from you. Yeah. So
what we can probably do, maybe if you have time and would like to, is maybe we could come back and do another hour on direct life affecting geology. So macro scale and then sort of personal scale geology. I would love to follow up with that if you would like to do that at some point.
This is great.
Awesome. Well, thank you so much for being here, and this is all really fantastic information, and I'm sure that it will get lots of people going and doing independent research, which is our goal, right? And writing cool things, which is our other goal.
Yeah, that's the goal, right?
Absolutely.
Awesome. Yeah, great.
So I think next week we were going to do footwear again because we just couldn't get enough of shoes. But so for now, I will say thank you, and I'm going to stop the broadcast.